Good morning, everybody. It's great to be here in San Diego with all of you and to be here part of the Power ecosystem. We're very committed and excited about some new capabilities that we're rolling out, as Steve mentioned. So I am responsible for our data center solutions business at Microchip. I think many of you may be familiar with Microchip as a microcontroller company. We have a broad range of products that serve a number of different market segments, including consumer, embedded, automotive. Back in May of 2018, Microchip acquired Microsemi and expanded into aerospace and defense, communications, as well as data center solutions. And within the data center solutions group, we are focused on connecting, managing, and securing the world's information by enabling connectivity solutions across storage, memory, and compute. And at Microchip, we very much believe that the future of the data center is going to rely very heavily on flexible platforms and composable platforms. And so we're directing our energies into those spaces across storage, memory, and compute. So a few comments about what we're currently focused on. We are looking at three distinct market segments: storage infrastructure solutions, endpoint solutions, and memory infrastructure, which I'm going to talk to you about today and follow on to Steve's topic of memory. So first in storage, we have our I/O controllers and our smart RAID solutions. We also have the industry's highest port density SAS expanders, and we are now very much focused on bringing all of those to Gen 4 speeds, including our industry-leading switch tech product line with PCIe switches that enable connectivity between CPUs, GPUs, as well as storage and memory. We also very much focus on enabling NVMe SSDs, which are the fastest and largest growing segment of storage as we look forward. And then finally, we've augmented our product roadmap now with a new focus on memory infrastructure. And a couple weeks ago, we announced a new product called the Smart Memory Controller. And basically, the SMC1000 has 8 25 gig OMI connectivity that is required for next generation CPUs and SoCs for a variety of high performance computing, including AI and a subset of that in machine learning. So we talked about this at Flash Memory Summit a couple weeks ago. This is a broad industry trend. OpenPOWER is leading in that transition. And this product specifically is designed and optimized to work with the IBM Power 9 Prime processor. If we think about composable memory infrastructure, we see innovation across two vectors: near memory and far memory. And the near memory innovation is really about how do I get more bandwidth to my CPU. As Steve just showed in his roadmap, the processor number of cores has increased from 8 to 12 and now to 24. And we're limited by the number of pins and the real estate that we have available on the package. And so it's really the serialization of memory that's going to enable us to open up that bandwidth to serve the needs of these applications. Second is far memory innovation, and this is really all about pooling memory resources and then sharing those across one or more machines. And that requires a number of capabilities, including fabric capabilities that we're investing in as well. We've been working with a number of partners in the ecosystem that are focused on these new open load store standards, obviously including OpenCAPI, but also the recently announced Compute Express Link, CXL consortium, as well as Gen Z. So there's no doubt this is a very important trend that's going to drive a new market segment around memory infrastructure. if we look at the key trends around latency and bandwidth, this is from an industry paper that is plotting the trends in terms of latency and bandwidth over time. There's really two takeaways to this. When you look at the number of cores that are increasing, the amount of memory bandwidth per core is actually going down. And likewise, the latency per CPU core is going up. And fundamentally, this is driven by the fact that our DRAM buses on our CPUs are limited both in terms of quantity and performance. We can't fit any more pins on the chip, and there are power and performance implications for the current architecture. That leads us to the product that I want to spend a few minutes sharing with you. We call this the Smart Memory Controller SMC1000. It has basically two interfaces, an 8 by 25 gig OMI interface to the processor, and a 72-bit DDR4 3200 interface to our DRAM. And there's really three primary values to this. The first and foremost is the bandwidth. Essentially, we're replacing a 288 DDR4 interface, 288 pin DDR4 interface with an 83 pin OMI interface. So effectively, we're able to quadruple the bandwidth with this solution that is moving the memory interface to a serial interface. And secondly, and Steve touched on this, is media independence. So by moving that controller outside of the CPU, we can now couple the innovation and development of those controller solutions with the new memory, whether it be some form of DRAM, flash, or storage class memory. And then finally, the benefit of lower total cost of solution. You have lower silicon costs in your CPU, you have fewer pins, and you have the ability to drive overall lower costs with less complex packaging. So this product will be available in the market in the form of DDIMMs. There'll be both 1U and 2U. We've been working with our partners at Smart Modular, Samsung Electronics, as well as Micron. And the production availability is aligned with the Power P9 processor. And samples are available today. If you join us out in the foyer later, we have a demonstration over at the Smart Modular booth. And Mr. Jay Bennett will be over there with us and be happy to talk to you more about our new solutions. So please come and join us. We're really excited. I think this very much is the first step in a number of areas related to memory infrastructure. As I mentioned earlier, the power ecosystem is leading in this space with IBM's processor architecture. Many others are going to follow through some of these other consortiums that I mentioned, first with near memory innovation, followed by more far memory innovation. We also have a technical presentation today at 4:45, so I invite you to join us for that as well. So with that, I'll say thank you for your time and looking forward to working with all of you. Thanks.